Okay, moving on, we're going to look at defining our trig functions with respect to any angle based off the terminal side of the angle's rotation. So let theta be an angle in standard position. So remember, standard position for an angle or rotation is the vertex at the origin, right, and the initial side with the positive side of the x-axis. And if we rotate counterclockwise, we have a positive angle or rotation. If we rotate clockwise, we have a negative angle or rotation. So with that said, you can see over here to the right-hand side, we've got an angle in quadrant 1. We see its terminal side there lying in quadrant 1. And we have this ordered pair, this point P, labeled by the coordinates of x and y, sitting on the terminal side of angle theta. And with that, we have what we call the radius, which is the distance from the vertex to the point xy sitting on that terminal side of the angle's rotation. With that said, we're looking at radius. Now, you talk about radius is the distance from the center to any point on the circle. And you can see this rotation, right? If we were to circle 360 degrees, or rotate, I should say, 360 degrees, we make a complete circle, and that would be the radius, right? The center would be at the origin if we're in standard position. And again, the distance from the center point to any point in the circle is all our radius. So you understand, again, where the radius comes from, a geometry review. With that said, if you think about your trig functions, all right, if you look at our two coordinates, x and y, we can construct a right triangle from that, right? In a rectangular coordinate system, we have a horizontal distance and we have a vertical distance, right? With the point xy, we've gone horizontally x units to the right, and we've gone y units up on the y-axis, right? For example, if that was the point 3, 2, we would have gone right 3 units and up 2. So that would be our horizontal and vertical distance. But you can see from that we've got x and y. And with the horizontal and vertical, we make a 90-degree angle. So we have a right triangle. So when we define these trig functions, we can go back to our first section. We look at the sine of angle theta. We look at the opposite side and the hypotenuse. Well, the opposite side of theta is represented by y. Y was the vertical distance traveled from our vertex, right, to that point. It's the y coordinate of this point on the terminal side. And then, of course, sine is opposite over hypotenuse. The ratio of those two sides and the hypotenuse is represented by the radius, the distance from the vertex to that point. So we see from that, if sine is defined as opposite of hypotenuse, we've proven with the right triangle that sine can be evaluated using the y coordinate of any point on the terminal side divided by its radius. So the ratio of y coordinate to radius. So sine of theta is y coordinate over r. We get the cosine. Let's get back to our definition of right triangles. Cosine's adjacent side. Right, here's our adjacent side. And hypotenuse, so it's x over r. So the x coordinate divided by the radius defines cosine's function. And then tangent, which we know is opposite over adjacent. Of course, the opposite side of theta is y. And we know the adjacent side is x. So it's y coordinate over x coordinate. So we can use right triangle trig, right, to prove our definitions here with these points sitting on the terminal side of a rotation. So you can pick any ordered pair on the terminal side. You can measure the distance from the vertex, which would be the center of that rotation, to that point. And we can use that distance, that radius, and the ordered pair to calculate our trig function values. And of course, beside sine, cosine, and tangent, we have their reciprocals, cosecant, secant, and cotangent, which you can see are the reciprocals of those. If sine is y coordinate over radius, cosecant's radius over y coordinate. If cosine is x coordinate over radius, we know that secant, which is the reciprocal cosine, would be radius over x coordinate, and cotangent would be x over y, since tangent is y over x. So defining our trig functions using ordered pairs on the terminal side of your angle. So you can see these definitions. here in our notes, and I've summarized those here on this slide and just showing you different rotations down below, right, and how we'd go about evaluating the trig function values for angle theta. So let's take that and apply that to an example. So let's move on to this slide here, and we look at this problem. It says find the 6 trigonometric function values for the angle shown down here below. So we've got angle theta. Now angle theta is an angle here in standard position. It's a positive angle. They're showing a counterclockwise rotation with the terminal side here in quadrant 3. And they've given us an ordered pair on the terminal side of this quadrant. Right? We've got our ordered pair XY. All right, so we've gone left 4 units and down 3. So you can see we've drawn in here in this picture. You can even look at it as a right triangle. We look at the horizontal and vertical distance. We form that right triangle, and we know what we need in order to go through our 6 trig function values is we're going to need the radius. We're going to need the distance from the vertex to that point, -4, -3. So we need to find the radius. So we want to go ahead and do that. So let's go ahead and calculate, right, the radius. Let's find r. So we know r, and we can do that using the Pythagorean theorem. Right? The Pythagorean theorem, right, will prove the distance from the vertex to that point. Proves our distance formula, because again, you can see radius, r, is the hypotenuse, and we got the 2 legs, we've got their lengths. So Pythagorean theorem says the square of the hypotenuse, r squared, equals the sum of the squares of 2 legs, which are represented by -4 and -3. So I got r squared equal to -4 squared plus -3 squared. And as we take that and we solve for r, we're going to need to do the square root. So let's go ahead and take the square root of both sides, and we get r equal to the square root of -4 squared, which is 16, plus -3 squared, which is 9, and that gives us r equal to the square root of 25, which is equal to 5. So our radius is 5 units in length. So there's r. So now we look at this right triangle. This is our 3, 4, 5 special right triangle. But we can go through now our 6 trig function values. So as we go through the sine of angle theta is y coordinate, right, divided by radius. So that's y coordinate would be what? -3 divided by the radius, which is 5. So sine of theta is -3/5. All right, let's go to its reciprocal. While we have it, we'll put the reciprocal right beside that. So we know the cosecant angle theta, which is defined as radius over y coordinate, would be -5/3 as we flip that. Right, reciprocal. And then let's go ahead and do the other 4. So as we go to cosine angle theta, by definition, is the x-coordinate of any point on the terminal side of rotation, divided by its radius, the distance from the vertex to that point, which in this problem is 5 units. And our x-coordinate is -4, so we have -4 over 5, at -4/5 for cosine's function value. And let's go ahead and put in secant. So we know the secant of angle theta, which would be radius over x-coordinate, would equal -5/4 for secant. And to finish it off, let's go ahead and look at tangent. We know the tangent of theta is y-coordinate divided by x-coordinate, which is -3 divided by -4. And -3 divided by -4, of course, will reduce to +3/4. So there's tangent, positive value. And as we go to cotangent, and cotangent of theta, its reciprocal function, should be equal to x-coordinate over y-coordinate, be equal to -4 over -3, or 4/3. Right? So we reciprocate. So they're the 6 trig function values. So we're given a angle. We were given a point on the terminal side of that angle. We went ahead and found the radius, and with that we were good to go with finding our 6 trig function values using our definitions that we just established, right, using rotations. So looking at our trig function values with any type of angle. All right, let's go to another example. Let's go to example A here. It says, given that tangent of theta holds a value of -2/3, and theta is in the second quadrant. So we've got a terminal side lying in quadrant 2. Find the other function values. So one thing we know, before we even begin, if you want, we know cotangent of theta. So we can go ahead and write that down. It's reciprocal. Be -3/2. There's cotangent. All right, but let's go back to what we were given. All right, so if we're given, right, the tangent of theta equal to -2/3, well, we know by definition, right? We know by definition this represents y coordinate over x coordinate. All right, and remember, theta is in quad 2. So I'm going to go ahead and draw a picture of this rotation. So let's go ahead and draw in this angle theta. So let's build in our x and y axis. All right, as we show this angle here in standard position. So we rotate over here to quadrant 2. Let's go ahead and show a rotation over here to quadrant 2. And let's draw in the terminal side. Here's angle theta in quadrant 2. And we're looking at a point on that terminal side. So let's go ahead and plot that point. So with that said, I'm going to put in this ordered pair here. We know that based off tangent's function value, we know that the x-coordinate and the y-coordinate have been given to us. So the x-coordinate would have to be -3. And the y-coordinate would have to be 2, right? Because we have -2/3 and we're in quadrant 2. So again, there's our x-coordinate, right? And there's our y-coordinate. As we go ahead and put that in there. And I'm going to go ahead and look at that while we have it. Let's draw in that horizontal and vertical distance. We've gone left 3, up 2. So with that said, we know the radius is the distance from the vertex, right, the origin, to that point. So I would need to go ahead and find r. So that would be my next step. Let's go ahead and calculate the radius. So again, we'll use the Pythagorean theorem. So to find the radius, right, Pythagorean theorem will do that for us. So we know that r squared is equal to x squared plus y squared, right, the two leg squares. So -3 squared plus 2 squared. As we take the square root of both sides, we can calculate radius. All right. So r, radius, equal to the square root of 9 plus 4, which is r equal to the square root of 13. So now we got our radius. So our radius equal to the square root of 13 units. So now we're good in finding all 6 trig function values. So we have tangent, cotangent. Let's go ahead and finish it off. So what would the cosine of angle theta equal? Cosine of angle theta is x-coordinate over radius. So that would be 3 over the square root of 13. One thing we don't like about that, remember when we have square roots in the denominator, we want to rationalize, create that square. So go ahead and multiply numerator and denominator by the square root of 13. As we rationalize, that's 3 square roots of 13 over 13. There's cosine of angle theta. Of course, that gives a secant. So we talk about the secant of angle theta. That would be radius over x-coordinate. That would be square root of 13 over -3. All right? And be careful. Remember, our x-coordinate was negative. Let's go back to my previous example. I forgot to put in the negative, so we're off a sign here. cosine negative in quad 2. That was a negative 3 squared 13 over 13. And just like with secant, it's a negative function value. It's equal to negative square root of 13 thirds. All right, finishing it off. Only thing we haven't done up here, let's go ahead and do sine. What's the sine of angle theta? Y coordinate over radius. And that's equal to, we got a positive y coordinate, 2 over the square root of 13. And as we rationalize, we multiply the numerator and the denominator by the square root of 13. We get 2 squared root of 13 over 13. And of course, that gives us our last function value. So we'll go ahead and write it in here. Once all of them, let's go ahead and put in cosecant. We know cosecant of theta is equal to what? It's equal to radius over the y coordinate. So it's equal to what? Square root of 13 over 2. Square root of 13 halves. The cosecant. But there they are. There are all 6 of them. So again, they've given us a trig function value. So again, we can use our definitions based off rotations, right? We got our coordinates, we've got our radius, right? We got our function value. They're giving us that information. We defined our trig function values using the ordered pair and the radius, right, with respect to the terminal side of that rotation. So let's take example B here. Cosecant of phi is given. Well, I should say theta, not phi. So what I'm going to do, let's go ahead and write in. We can go ahead and write in one of the answers. We know that sine of angle phi, or sine of theta, would be equal to the reciprocal. So it would be negative 5 over square root of 26. And that we would need to rationalize. So we multiply numerator denominator by square root of 26. We end up simplifying down to negative 5 square root of 26 over 26. So there's one of the answers. There's sine using reciprocals. But again, let's take our given information. So let's go ahead and look at what we had to work with. So based off what's given, we have the cosecant of theta equal to negative square root of 26 over 5. Now remember, definition of cosecant, which is reciprocal of sine. Sine is y coordinate over radius. That means cosecant's radius over y coordinate. So let's draw our picture. So let's construct a picture so we can see a picture of angle theta here. Now, what does it say about theta? It says theta is in quad 4. This is a quadrant 4 rotation, so in standard position. Vertex at the origin. So we rotate to quad 4. Draw an angle over here in quad 4. There's theta. Now we're given again radius, square root of 26, which is 5 point something units. And we're given y coordinate, and y coordinate, of course, would be negative 5, right? We're down in quad 4, y coordinate is negative. Let's go ahead and draw a picture. Again, this ordered pair here label. So here we got our ordered pair. So we have a x coordinate we don't know. We know the y coordinate would be negative 5. And we know the radius, right, the distance from the vertex to that, which is r. R is equal to the square root 26. All right, so the only thing we're missing is x, the horizontal distance. So let's just draw in a picture and use right triangle. So here's x. Of course, we've gone down 5 units. There's y. So we need to find x. That would be our first step. Right? So we got y, we got radius. So let's use our Pythagorean theorem. So to find x, Pythagorean theorem will do that. We can use our right triangle. So r squared, so the square root of 26 squared equals sum of squares of 2 legs. One is x, our unknown. X coordinate, horizontal distance, plus the other leg, which is down 5, negative 5 or 5, however you want to write it. Negative 5 squared. So we simplify that. We get 26, right? Square root of 26 squared equal to x squared plus 25. As we simplify that. So again, as we're looking at finding this missing information, we've got x squared equal to, and let's go ahead and solve that. So we're going to solve, we'll go ahead and move that 25 over, subtract it, and that gives us x squared equal to 1. And it means we take the square root of both sides, right? We got x equal to 1. And again, we're going to write 1 unit. So that's our x coordinate. So write 1 down 5. There's x. So we found that missing piece right in there. So there's the x coordinate. X is equal to 1. So using the Pythagorean theorem, right, we were able to find, right, that missing piece based on what we had in front of us. Now we've got everything we need. So now that we have our ordered pair, we have our x coordinate. Let's go ahead and answer cosine. Cosine of theta is x coordinate over radius. So that would be 1 over the square root of 26. And as we rationalize, we multiply numerator and denominator by the square root of 26. All right, what do we end up with? We end up with square root of 26 over 26 for cosine of angle theta. And if you want, let's go ahead and put its reciprocal function, the secant of theta, which is radius over x coordinate. So that would be equal to the square root of 26 over 1, which is square root of 26 for secant. And to finish it off, only thing we haven't answered is tangent and cotangent. Tangent of theta, defined as y coordinate over x coordinate. So that will be negative 5 divided by 1. So tangent is negative 5. As we go to the reciprocal, as we go to cotan of theta, that's x coordinate over y coordinate. So that'll be 1 over negative 5. So negative 1/5. And there are 6 trig function values. So again, given a different trig function, just getting a picture of what we have, drawing in that rotation, drawing in that point and radius that we were given based off the function value. All right, let's build on a little bit. Let's do a couple other good examples. Here's a couple problems to look at. It says here in these examples, the terminal side of angle theta in standard position lies on the given line in the given quadrant. Find the sine of theta, cosine of theta, and the tangent of theta. So they give us a little information about our rotation. Let's see if we can visualize it and get a picture. So we've got a quad 2 angle. Terminal side lies in quad 2. And the terminal side lies on the given line. All right. So terminal side, all right, lies on this line. So what I want to do, let's go ahead and take, this is my first step. Let's go ahead and put this line here in slope-intercept form. So 4x plus y equals 0. The first thing I'm going to do is go ahead and solve for y. Negative 4x, move that over. We want to get it in our preferred form with a linear equation. We like slope-intercept form. So y equals negative 4x. So yeah, there's slope. I'll make a note. Slope-intercept form, right? Y equal mx plus b form. So that implies our slope, right, is negative 4. And our y-intercept is the value b, which is our constant term, which is 0, right? B is 0 in this problem. So with that said, now remember slope. So remember slope is the value of m, is your rise and your run. So I'm going to write that as a fraction. So your rise over your run. Just reviewing definition of slope. So that would mean what? Down 4 units, right? Or we could put the negative in the denominator, which I want to do. I'm going to move this negative. All right, that says down 4 right now, and right 1 unit. All right, Or we could write it as what? We could write it as 4 over -1, right? Again, your rise over your run is still -4, which means up 4 units and left 1, which I like because I can use that. All right, let's go ahead and take that information and let's draw a picture of this rotation. So let's go over here and graph in what we have. So as I look at theta, so again, let's graph this line. So we know we have a y-intercept, and we can put it here in a different color if you want. Y-intercept at the origin, there's 0, 0, y-intercept point. And now I can use the slope. So the slope said we can go up 4 units, 1, 2, 3, 4, and left 1 unit. So that would put me right here at the point -1, 4. So there is a picture. Let's graph in this line. So we're drawing in this line, right? And you can dash in this part. Here's the graph of the line, y equal to -4x, right? This is the graph of 4x plus y equals 0. So there's the angle. Now remember, this angle in standard position is a quad 2 angle. So here's theta. So I can wipe off. I don't need to worry about this part of the line. So you could erase that, right? We don't even need it. But there's our graph. So with that said, now we can calculate exactly what we need. So if you're looking at, and you can form your right triangle if you need to, left 1, up 4, right? I got -1 and 4. So we could find the radius. Let's find r. Do that over here to the side. Find r squared equals what? -1 squared plus 4 squared using Pythagorean theorem. So r squared equal 1 plus 16. So r squared is equal to 17. As we take the square root, we got r equal to the square root of 17 units. So there's our radius, right, based off those coordinates. So radius equal to the square root of 17. So now we've got everything we need. So we're looking at our 3 trig function values. So with that said, let's go ahead and answer those. So what's the sine of angle theta? Y coordinate over radius. So y coordinate is 4. Radius is square root of 17. As we rationalize, we can go ahead and rationalize. I'm going to create the square in the denominator. We end up with 4 square roots of 17 over 17. There's sine of theta. And with cosine, we can go ahead and put in cosine. Cosine is x coordinate over radius. So that will be -1 over square root of 17. And as we rationalize, multiply numerator and denominator by square root of 17, we end up with negative square roots of 17 over 17. And then to finish it off, what's tangent? Tangent of theta is y coordinate over x coordinate. So that's 4 over -1. So that's equal to -4. And there they are. There are 3 trig function values, right? Given, again, terminal side lies on that line and the quadrant 2 rotation. So we draw a picture of what they give us. So we had to draw in a graph of that line, and I did that using slope-intercept form, right? Y equal mx plus b form. So again, I identify my slope and my y-intercept, and then graph the line. So sketch a line. All right, we'll make that note here in our notes. All right, so with that, let's do another example. Let's take a look at 32. Let's see if we can do this one on our own. One thing I like about 32, our given line is already in slope-intercept form. So we got y equal to 0.8x, which is y equal to 8/10 x. Right, if we reduce that, of course that reduces down to 4/5 as we divide out our common factor, right, of 2. So you can go ahead and do that as we reduce that down. And that gives us 4/5. All right, and then you can apply your definition of slope and graph in the line. So let's go ahead and do that. Let me get my pen catch up. So again, that reduces down to 4/5. Right. X. So remember, there's our slope-intercept form. So that implies M, our slope, is 4/5. And our y-intercept, which is our constant term, again, is the origin. So as we get a visual, what we have in front of us, let's go ahead and draw in our x and y axis. Remember, this is a quad 3 angle. So let's go ahead and talk about the slope. To be in quad 3, I'm going to define my slope as -4 over -5. Right? Remember, that's our rise divided by our run. So down 4, right? And left 5 units. So let's go ahead and draw that in. We'll put it in blue, give it a different color. Here's the vertex. We go down 4 units. 1, 2, 3, 4. We go left 5 units. 1, 2, 3, 4, 5. We're down here at the ordered pair of -5. What? -4. So -5, -4 is our point there on the terminal side of this angle we'll be able to use once we draw in this line that we found. So again, you can go ahead and graph your line. And remember, this side here, we're not going to need. But this is our sketch. Here's the sketch of y equal to 0.8x. And remember, theta in standard position was a quad 3 angle. So just showing that terminal side rotation. So we got our x-coordinate, we got our y-coordinate. We just need to calculate the radius. So let's go ahead and find the radius, the distance from the vertex to that point. So find r. And to get r, remember, we've got our Pythagorean theorem. We can prove that the radius using the Pythagorean theorem. We've gone left 5 units. We've gone down 4 units. All right, so again, with that, we got r squared equal to -5 squared plus -4 squared. So r squared is equal to 25 plus 16. That implies r squared is equal to what? 41, which implies r equals the square root of 41. So there's your radius. So now you're good. Now you can answer your 6 trig function values. They've only asked for 3. So let's go ahead and answer those. Let's go ahead and draw a line around this last one. So what would that give us? So with sine of angle theta. Sine of theta is y-coordinate over radius. So that would equal our y-coordinate, which is -4. Our radius, which we just found, is square root of 41. As we rationalize, that'll be -4 square root of 41 over 41. There's sine of theta. We know the cosine of theta would be the x-coordinate over the radius. So that would be equal to -5 over the square root of 41, which simplifies down to -5 square roots of 41 over 41. And then, of course, tangent. We can go ahead and put in tangent. We'll put it over here. Y-coordinate over x-coordinate. So that would be -4 over -5. So 4/5 be tangent. And there they are. There are our trig function values. So getting a picture using the terminal side of that rotation. So that's a good stopping point. We'll take a break and we'll continue on here in a little bit.